So in this video, we're going to head to 1.4. We're going to look at some definitions. 1.4 is all about angles. If a figure is an angle, then it is formed by two rays with a common endpoint. And I gave us a little diagram here. So this is our angle example. And I know you all know what an angle looks like, but what's going to be important is how it is labeled and named. So you can label an angle or name an angle in a variety of ways. First of all, we have this angle. It's going to have to have, they're going to have a common endpoint, and then they're made of two rays, and those rays will also have points on them. So I'm going to call this point here A, and then our common endpoint B, and then over here C. And those three letters are actually one way we could name our angle. This would be angle A, B, C, and the vertex always needs to be in the middle. Also, when you have a single standalone angle like this, you could name it simply by its vertex, angle B. And sometimes you'll also see it with a number inside. So maybe if there's a little 1, we could call this angle 1. Sides of an angle. So for the sides of an angle is made up of rays. So those rays are also the sides. If a figure is the side of an angle, then it is one of the two rays that form the angle. So if we are looking at at angle ABC, the two rays that form the sides would be rays BA and ray BC. And it's important that when we name those, we start with our vertex. The vertex of an angle, that says if a point is the vertex of an angle, then it is the common endpoint of the two rays. So point B here would be our vertex. And then these should be familiar to you. An acute angle. If an angle is acute, then its measure is between 0 and 90 degrees. Right angle. If an angle is right, then its measure is 90 degrees. Something that's important to point out with a right angle, something might look like a right angle and not be a right angle. It's very important to see what kind of information you're being given. Sometimes you'll directly be given angle measurements. Sometimes you'll have to look at your picture for additional information. And keep in mind, you've seen this at some point, your little box, that's our right angle box, and that will indicate 90 degrees to you. But if you don't see that right angle box, and you're not told somewhere else that it is for sure a right angle, you cannot assume it. Obtuse angle. If an angle is obtuse, then its measure is between 90 and 180 degrees. A straight angle. If an angle is straight, then its measure is 180 degrees. So that also, a straight angle is also formed by opposite rays. So that's something to tie together. Congruent angles. If two angles are congruent, then they have the same measure. So we have these two angles here. Let's call these angles A and B. We'll name those by their vertex. One thing you might see in a picture, if two angles are congruent, is they'll put a little arc in the angle. So one little arc in each signifies they're congruent. Two little matching arcs would signify they're congruent, and so on. Very similar to the dashes that are used with segments. And then if you were to see this written out, you might see angle A is congruent to angle B, written like that. That's using their names. If we were referring to their measures, their degree measures, we would put measure of angle A, so that little M stands for measure. So measure of angle A is equal to the measure of angle B. So the first way, when it's congruent, that's using their names. And when we use an equal sign, it's because we're referring to the actual numerical value. Next, we have adjacent angles. If two angles are adjacent, then they are two angles that have a common vertex and no common interior points. So we're actually going to draw a little picture for this. I'm going to draw a little angle here. And then what I'm going to do is right off of it, I'm going to draw another angle. I'll label these 1 and 2. These would be adjacent angles because they share a vertex. And they don't overlap. They don't share any common interior points. So that would be a basic example of some adjacent angles. Bisector of an angle. The bisector of an angle is normally a ray. So if a ray is an angle bisector, then the ray divides the angle into two congruent angles. So here we have an angle on our right. I'm going to call this angle A, B, C. And then I'm going to draw a bisector. So I'm going to put a ray going as close to the middle as I can, and I'm going to call that ray BD. Now, if this is a bisector, then that means it is going to divide your angle into two congruent angles. So we can put our congruent arcs. They would also have to have the same measure. For example, if this angle was 20 degrees, this angle would be 20 degrees. So that's what that would look like. Something you might notice, bisector of an angle and bisector of a segment are a little different. The bisector of an angle is directly what splits that angle into two congruent angles. But when we're talking about the bisector of a segment, the bisector of a segment goes through the midpoint, and then it's actually the midpoint that splits the segment into two congruent parts. So that's a little bit of vocab to keep straight there. And then our postulates for 1.4, don't worry about the protractor thing. That's mainly about being able, and that's in your textbook. If you're following along in your textbook, there's a protractor postulate that goes along with just like measurement and understanding the degrees. I'm not worried about that with you guys. So our angle addition postulate says if x is in the interior of angle ABC, so let's draw that. I'm going to draw an angle. Should look better. So I'm going to draw an angle, and I'd like you to follow along with it. So I'm going to call this angle A, B, C. And it says X is in the interior, so you can put point X anywhere on the interior there. And we're going to need to connect that with a ray. Sorry, it's challenging to draw on this tablet. Okay, do the best you can. So now we actually have two different angles here. And what our angle addition postulate says is that the measure of angle ABX, so that's this angle here, the measure of ABX, plus the measure of angle XBC, that's this angle here, is going to give you your entire angle, the measure of angle ABC. And there should be a little m here. Let's add that in. Okay, so it's very similar to the segment addition postulate, just in terms of angles. So then the second part of our angle addition postulate says if angle AOC is a straight angle, so let's draw angle AOC, and B is any point not on line AC, so I'm going to put point B up here, and then connect it with a ray. Then the measure of angle AOB plus the measure of angle BOC equals 180 degrees. And the reason for this is because a straight angle is going to be a 180 degree angle. So if you take your individual parts here, like angle AOB, and add its measure to BOC, you're going to get a total of 180 degrees. And then in our next video, we're going to look at some examples.